wrote an email. They haven't gotten back
I
to me.
saved you 2 cookies. One more? Someone stole an art pencil. I love that.
I have presents for you. We don't have a lot of time. It's going to take the full time to get through it if we do. Last class did not get feedback on the last class.
Yes, I saved you 2.
And that's okay because they had questions. But they also have the amount. So that's
Oh, we'll get this up pretty fast.
I haven't had one. There was only like 50 and everyone liked them. Like,
Pardon me.
I went on, took them to lab and I had them in a black bag.
How are you?
Oh,
But I had them in a bag, so no one saw them.
Hey.
And then nobody ate them in my class because it was like a party.
You will. Every other
On the way back, I didn't put them in the bag. So when I got them, all the boys were like, and they're like, oh my god.
We're big feedback. Yeah, you are, boys. I'm going to kick your butts. Ask anybody in this class. This is the hardest class I've ever taken, period.
Stop.
No questions.
You're
Make
me.
you cry every fucking night before you go to bed.
Okay,
So you graduate this class as a girl.
Oh, you got me there.
You do. That's probably the best idea. Yeah. Honestly, that's my advice for everyone. Just drop out, guys. Drop out.
Oh, I remember this.
That's right. Don't plug it into the same equation. Yep. All right, go away, gentlemen. Get to class. Go, go, go. Hurry. I'm starting now, guys. I got you full screen, by the way. The program updated about a month ago, and I found a feature that allows it to do this. The thing I'm using is not meant for teaching, it's meant for streaming, right? But it has the thing now, so we're good.
Can I use some pens?
Of course, go, go, go.
How many would I need?
You what? Don't take from my thing or the thing's laying there.
I can take from this one?
Yes.
Okay, that's what I was thinking.
Hey, Mag, what is this?
What other color?
That's a thing for classical guitar playing. You put your foot on it and it props up your leg so you can hold the guitar.
Yep.
How many colors would I need for max? I have 4.
I don't know. I think 4 or 5 would probably be fine. No Zayden again?
Nope.
Yikes.
Sorry, I'm like this
What's wrong with this?
Wait, Zayden was last out. Yes, okay, that's fine.
Why don't you just get a guitar strap? That's so much easier.
That doesn't work for that type of thing.
Oh, wait, yeah, that actually makes sense.
Yeah, okay, moving on. Alright.
I'm stupid.
Here we go. I'm getting started now.
Hey, why is it muffin?
It's cool.
Wait.
They're not yours.
You know what? I'm dumb as hell again.
Alright, here we go. Yeah, right here. What? You can do whatever you want, man, but I'm starting. All right. A, B, and D are parallel. So we know this. We're going to prove these two triangles similar. Ooh, that's right. I'll give you guys a little bit of this drink. So. All right, if you're going to talk during announcements, I will just go. So we're going to prove this big triangle similar to the small triangle. Remember, we have 3 ways to prove triangles similar. A similarity, side angle side similarity, where the sides are proportional with an angle in between, and then side side side, where all sides are proportional. When we talk about side angle side similarity, what we're talking about is that 2 of the sides are similar. So, for instance, so notice these 2 sides right here are proportional because 3 versus 9, 4 versus 12 is the same relation, right? Times 3, right? Do we have enough information to say these are similar though? No, 2 sides ain't enough. But if I knew I had an angle in between, I would, right? Guaranteed. Okay? Now they have to be related the same way. So if this were 3 and that's 9, and this was 4 and this was 16, yeah, 4 and 16 relate. Times 4, right? But 3 doesn't relate to 9 the same way, right? That's times 3. So they would not be similar, right? They have to relate by the same thing. That's what it means to be proportional. So these would not be, right? 3 times 3 is 9, 4 times 4 is 16, not 4 times 3. Cool. What do you see? Yep. Now, vertical angles, linear pair, and shared angle are something you're going to see tons of, and very quickly you can mark your whole diagram with them, right? Now, is this shared angle here going to be useful? Yes, because it belongs to a triangle I'm interested in. What's up? A triangle I'm interested in, and another triangle I'm interested in. So yes, I will mark it down and it will be useful. Katie, what's your question? Yes, we're going to get there.
I am still trying to listen.
Yes.
It's so hard to hear.
What's up? To the announcements? Oh, I'll stop then.
No, it's fine.
Nope, I'll wait. What's your question, Andrew?
I'm really stupid. Why is that a shared angle? Is it because it's a linear?
Mr. Mag, I don't think I got one.
Is it because the triangle's isosceles and that's why C is a shared side, or?
No. So, the small triangle uses angle C. And see how the big triangle overlaps with angle C? No, you're not. These are questions that are easy to answer, but they cause huge issues if you don't know it. So you have to ask those questions. Thank you for asking it. So C is a shared angle because it's used by the small triangle and the big triangle. Okay? So, we have an angle pair between the small and the big. If we had another angle, we'd be able to win. Now, Katie's right. We have two parallel lines. Whenever we have parallel lines, we should be looking for corresponding angles. Remember that if we have two parallel lines and they're cut by another line, we call that line a transversal, right? Then if the lines are parallel, then corresponding angles will be the same, like those two angles, right? So if you look, don't I have two parallel lines cut by a transversal, right? A line that's cutting them. So corresponding angles will be congruent. So, for instance, these two angles are corresponding because they're both top right corner of their intersection, right? Right, see how that's the top right? That would be top right if we extended it. So the corresponding angles will be congruent because the lines are parallel. So we're going to say by cap, angle CDE. Can't just call it D, right? Because there's two angles there that are D, right? This angle, CDE, will be congruent to this angle, CAB. Could you have called it DAB? Sure, right? But I'm going to call it CAB. How do you feel so far? Yep, today's a magical day.
Are you able to extend the lines to make it easier?
Yep, you can do that to help you see it, right? So it's easier to see something like that. That's always fine. If you extend it, make sure you tell me that you're extending it and what point you're extending it into. But yeah, so could I do it for this side as well? Yeah, because we have two parallels cut by a transversal, so these corresponding angles would be equal, right? They'd be a different color because they're not equal across, but I don't need that because I already have two angles, don't I? Yeah.
Don't we have angle?
We do, right? We've already got enough information. Two angles here, a purple and an orange. And in the big triangle, right, again, ignore that, we're talking about the big triangle. We also have a purple and an orange. So by angle, they're already similar. So that's what I'm going to write next. Mark.
I kind of forgot, what's the difference between cap and cap converse?
I'll answer that in just a second. Angle, similarity, matches up the top triangle. Oh, actually, let's do the big triangle first. Let's do triangle ABC. That's the big guy, right? Now, if I wrote ABC, A in the big triangle is orange, right? Do we see that? Right. So what's orange in our small triangle? D. So A and D must go together. B in our big triangle is this angle right here, and it's the unknown angle. So it's not orange, and it's not purple, right? Those are the other two angles in our big triangle, right? So if I go here, what's not orange and not purple? E, right? So they must go together. In fact, they'll be congruent by CSP. Or we could have proved it by cap, right? Corresponding similar parts. Okay. C, well, in our big triangle, it's the purple angle, right? What's the purple angle in our small triangle? Also C, because they overlap, right? Cool. So, Mark, you asked about cap versus cap converse. You're going to have to watch, okay, because the diagrams are going to look the same. So here's cap. It's when you have two parallels, you get these two. Cap converse is if I have these two, then I get the parallels. Does that make sense? It's just in reverse. Now, not all theorems work in reverse. This one does, okay? So if I have two corresponding angles, they're corresponding, top, left, right? Then the lines must be parallel. Cap says if the lines are parallel, which they is, then corresponding angles, like my top left and top left, would be congruent. I'd also get that these would be congruent, right, because they're both top right. Cool. So we're here. The triangles are similar. We go with that. McKenna, you with me? Awesome. So now that they're similar, I can use CSP. Remember, it's like CCP, but for similar triangles, right? That allows us to talk about their parts. But we don't need it, right? Because we're done. That's all they wanted. Now, what if they wanted us to show that DE was related to AB? Well, look, DE is first and second. AB is first and second, so they would be related, right? What if they wanted to show that angle E and angle B were the same? Well, angle E is angle CED, and if I look, CED is third, second, first, right? It should be congruent to angle CBA. CBA, yeah, right? That's all CSP is. It's matching up the letters. Now, can we do that if we don't know the triangles are similar? No, because we have to have something like this to look at. Notice I'm talking about triangles here, not angles. Don't look at this and think, oh, time to use CCP, right? Or CSP. No, those are angles. When the triangles are similar, you can use CSP, right? Cool. Let's look at number 2. It tells you that BD and AE are line segments. So all that's telling you is that, yeah, your eyes do not deceive you. That is a straight line. There's no bend at C. Okay, it doesn't bend just slightly and you just can't tell. That will be a linear pair here and here. AE, straight line, okay? B and E are congruent angles. That's what this means. Again, one of the reasons I like using colors is so I can tell where I got stuff from. If it's green, I got it from the given, right? Because I circled that, and that's where it came from. Yeah?
So on the test, do we have to like write down the given, or can we just mark it on the?
You just mark it on the diagram. The given's already written down for you. It's okay. Yeah.
Are we able to do angle BCA is equal to angle ECD by a linear pair theorem?
It's not linear pair. So linear pair is when you have something like this.
Oh, vertical
right?
angles, vertical angles.
Yeah, two angles on a line is a linear pair. Two meaning pair, linear meaning line, right? That means they will add up to 180. I don't know what they are, but that plus that will be 180, right?
So
What you're saying is vertical angles.
Yeah.
Vertical angles is when we have an X, right? That means always these guys will be the same, and these guys will be the same. That's scissors theorem, right? If I have an X, notice how the top here is the same angle as down at the bottom, right? And notice the sides are also the same. Even if I change that X, no matter what I do, top will always be the same as the bottom, sides will always be the same. That's vertical angles theorem. So if you look, because BD and AE are straight lines, we have scissors going on here, right? That means these two are congruent, and these two are congruent. Now, I don't care about these two because they're not related to my triangles. Again, vertical angles you're going to see all the time. And if you start marking all of them, your diagram is going to be full of stuff, right? So mark the ones that are useful. These two are useful, right? So I'll mark it. So by vertical angles, these two are the same. Now that wasn't given to me, so I have to write that down. By vertical angles theorem, can I just call that angle C?
Yeah.
Mm-mm. There are multiple angle C's. Look, I've got one here, I've got one there, I've got one on top and bottom, right? So I can't just call it angle C. It's like when you have a kid with the same name, right? A bunch of kids with the same name. You have to use their full name. So we can't just call it C, we have to use the full name. Let's call it BCA. Could you have called it ACB? Sure, right? It's the same angle. ACB is the same as BCA, right? But C has to be in the middle because that's the vertex of the angle, right? And then the other one we can call ECD or DCE. It doesn't matter. As long as C's in the middle. Do we have enough information to now prove the triangle similar? Yeah. Right? By angle, angle. Triangle, let's do ABC first. That's the left side triangle. I try to write the first triangle in alphabetical order when I can. You don't have to. But if I wrote it ABC, then I need to do the letters over here in the right order too. So A is this unknown angle. See how in this triangle it's not green or blue? So it's whatever's left over, right? 180 minus the green minus the blue, that's what this guy is, right? Well, this guy also is going to be 180 minus green minus blue, right? They're both what's left over. So they must be the same angle, right? If the triangles are similar, all the angles should match up. So these two have to go together. So D goes in A spot, first spot, right? B is green in this triangle. What's green in the other triangle? E, so they go together. C is blue, and of course it's vertical with the other one, so they're both blue, so they both go together, so C. Okay. If you had written CBA over here instead of ABC, you'd have just written CED over here, right? Do you see how the order you pick here influences what happens over here? Okay, good.
Are we able to, for the next, are we able to just subtract the C off of each of these?
What do you mean?
Off of each triangle to find the AB equals DE?
AB, are you talking about a line segment or an angle?
Line segment, because if we were to...
Nope. Mm-mm.
Oh, damn.
This triangle could be smaller than this one. We know they're similar, meaning that they're related, but they're not necessarily congruent. Okay? Remember, congruency is much harder to prove. AA is not one of the things we can use for congruency. All right, so because the triangles are similar, their parts should be. Now, we could prove that A and D are the same angle because similar triangles have congruent angles, right? But we don't care about that, right? What we care about are their sides. AB, BC, CE, and DE. So when we want to compare sides, right, once the triangles are similar, we use CSP, just like we talked about earlier. So by CSP, I'm allowed to match up the letters. Right? Once I have the triangle similar, which I just did, I can match up the letters. Well, we know that AB is in the first and second spot, right? And so it should be proportional to what over here?
DE.
Good. CSP stands for corresponding similar partners. Corresponding means same relative location, right? AB and DE are in the same relative location. They're both first and second. And they should relate the same way that BC does to what? Very good. Again, don't forget your equal signs. Remember, they should all relate by the same thing. Half, double, triple, quadruple, right? They're all going to have the same relationship. The sides might be different sizes, but they're all going to relate to each other the same way. And then lastly, everybody forgets about AC because it's first and third. What's it going to relate with? Yep. Mm-hmm. Cool. Now, I actually don't care about all these sides, right? All I care about is AB, BC, CE, which is the same thing as EC backwards, right? And DE. So I don't really care about this guy, right? It was true, so I wrote it. But these are the ones I care about, okay? So I want it to be multiplication, and I want AB and BC to be on the same side. See how AB and BC, oh, whoops, sorry. I forgot. I tried to correct it between periods. I didn't, my bad. Change this stuff at the top. Should be this. That's what we want. I was going to change it during second hour. I literally used the worksheet we used this week, right? This last 2 weeks. And I forgot to change letters there. My bad. I was going to change it during second hour, and then I forgot, and then I printed 100 of them, so here we are. Yeah.
Are we able to just multiply EC by AB and then the DE by the BC?
Yeah, so we're going to multiply EC over. So I'll show you how this works. I'm going to focus on just these ones. And when I rewrite it, which you don't have to do, but I'm going to do, I'm going to write CE instead of EC because that's what they want, right? Okay. Or at least they did before I turned it to EC up here. Whatever. All right, so we're here. Okay, we cool with that? I just ignored this guy. All right. So I want to move CE over with AB, and I want to move BC over with DE, right? So how do we get something out of the bottom of a fraction? Well, fractions are just division, right? How do we undo division?
Multiply.
Yeah, so I'm going to multiply by CE to move CE over. You don't have to show this. I'm just showing you how, okay? Now, why does this work? We talked about this before. Fractions are just multiplication in the top and division in the bottom. And I can do it in any order I want. So I can times first and get BC times CE and then divide by CE. Or I can divide first. Now, if I divide first, I think it becomes obvious. CE divided by CE, what's that? Try it again. What's CE divided by CE? 1. So this is just 1, right? It doesn't go away. It becomes 1. And what's 1 times BC? BC, right? That's why we did it. Right? It makes CE go away, right? And then over here, am I going to get anything to become 1? No, because it's CE divided by DE. That's some number. And then we're going to times by AB. So all that is we're going to write CE times AB. Remember, multiplication happens in the top. Division happens in the bottom. All right, I got CE and AB together. I need to move DE over. How do I do it? Multiply both sides, otherwise it's child abuse, right? We can't have that on YouTube. So multiply both sides by DE. Over here, we have DE divided by DE. So what happens? It becomes 1, right? And 1 times anything is just itself. So it's 1 times CE times AB equals BC times DE. Again, I wish you guys had me for algebra. Now, we almost have what they want. They want us to flip some things around. Now, why are we allowed to write this? Oh, I'll write, yeah, I'll do CE. That's fine. Why are we allowed to write that? It's not going to change anything, right? Isn't 2 times 3 the same thing as 3 times 2? So with letters, it should also be true, right? CE times AB is the same thing as AB times CE, right? So we're done. Probably should make that EC up here a CE. But either way, yeah. You are not allowed to change the proof, the proof part on your quiz. Yes? I don't know, but it can't be more than what's on here. Let's look at 3. They tell you that C is the same angle as DEA, and it's all 90. So angle C is this angle. And angle DEA is this angle. That's 90. Now we know if we have these 2 angles are a linear pair, right? So that means they add up to what? 180. Yep, so if one of them's 90, what's the leftover have to be? Also 90, right? You don't need to write that it's linear pair. You can just fill it in. It's not going to be very useful. That's why I didn't color it in. But it's true. Now, we want to get these parts together. So we want AD and BC, AB and DE. Well, luckily we only have 2 triangles, so really what we got to do is get this small triangle similar to the whole big thing, right? That's what we want. And then we'll use CSP to get their parts, and then move stuff around. Okay? Feeling okay? All right, so right now, the small triangle has a right angle, and the big triangle has a right angle, right? Its angles are A, B, and C is its right angle. So we have already one set of angles. How can we get another? Yep. See how the small triangle uses angle A? And the big triangle also uses all of angle A. So they're shared. They do not share D, right? Because angle D isn't even a part of the big triangle. They don't share E, because again, angle E isn't even a part of the big triangle. It's perfect overlap. So that's what a shared angle is, yeah.
How do you know that angle C is 90 degrees, Ken?
They said it was measure of angle C is equal to measure of angle DEA, and they all equal 90, right? Nope, it's okay. I love small questions like that. Those are the most important. So these angles are shared, right? A in the small triangle, and then A in the big triangle. So that's a shared angle. Now the small triangle has a purple angle and a right angle, and the big triangle has a purple angle and a right angle, right? So by AA, they're similar. Triangle. Small triangle, let's start with that first. I'm going to call it ADE. In our small triangle, angle A is purple. What's the purple angle in our big triangle? A, right? It's a shared angle. Right? Our big triangle consists of angle A, angle B, and angle C. Right? D in the small triangle is the unknown angle. It's the leftover, right? So what's our leftover in our big triangle? B. No yawning in math class. Angle E in our small triangle is the 90 degree. What's the 90 degree in the big one? C, not E. Right? That angle doesn't belong to the big triangle. It's this guy. So ADC. Good job. So those two are similar. Well, if they're similar, can't we say their parts are related? We could also say that angle D and angle B are congruent by CSP, right? Because they match up, right? But I don't care about that. I care about their sides. So we're going to say by CSP, AD relates to what on the other triangle? AB, because they're both first and second, right? The same way, don't forget your equal signs, that DE relates to BC. The same way that AE relates to AC. Good. Now, I don't care about all those sides. The sides I do care about are AD and BC. So here they are, right? And I care about AB and DE. So I don't care about this last guy. That's fine, right? If I didn't care about the middle, I could cut him out too. Doesn't matter, right? So all I care about is that. Could I rewrite it? Sure, but I'm not going to. I'm just going to know that in order to move things around to get it to look like that, what am I going to do to the BC? What am I going to do to get rid of that BC in the bottom? Multiply, right? I'm going to multiply it over. So what I'm going to end up with is AD times BC over here, right? Still divided by AB, right? So how do I move over the AB? I multiply that, right? So I'll write that. You don't have to show your work for multiplication if you don't want to. Does everybody see how I got from here to here? That's key. Do you see it? I moved over the BC by multiplication. I moved over the AB by multiplication. Cool. If you want to show your work like we did in number 2, you can. Andrew, you getting it?
Yes, it's been like 2 weeks.
Yep, I know. It takes 2 weeks. Yep, I knew it. Called it. I should do a thing at the beginning of the 2 weeks, and I should have like an envelope and be like, in this envelope, I have a secret thing, right? And at the end of the 2 weeks, I'm like, I reveal it, and it says it'll take 2 weeks for you to understand this.
My mom says that all the time, word for word what you just said.
Wow, that's amazing. Guys, at the end of the day, lots of factors in your education, right? Like where you come from, your socioeconomic status, lots of things, right? But the biggest thing by far, both good and bad, is that it takes time to learn. This is a good thing because that means everybody can learn, it just takes time. The bad news is that it takes time, right? And not that the other things don't matter, right? Your educational background, your social status, right? What class you're in, right? Affects a lot of things. Race, gender, all these things, right? Things that you've experienced in your life that, make you who you are, make us individuals. Those things matter. But the good news is they don't actually matter as much as time. They can all be overcome by time. And some people need more time than others, and that's okay. Doesn't matter how long it takes you, as long as you get it. All right, are you with me? Because we got 3 more to do, and we're not going to get through them all. And they're all going to be on the quiz, more or less. Here we go. AC and BC are the same. That's the perpendicular sign. Perpendicular means what? Nope. What does perpendicular mean?
90.
It means they're 90 degrees. So that means ED is perpendicular to AC, so it hits it at 90. Both are 90s because they're a linear pair, right? I also know that EF and BC are perpendicular, so they must be hitting at 90. Cool. I like to color in one and not the other so I can tell there's, 2 different boxes. I don't know. Yeah, it does. I think color helps too, because then you can see up here where I got my stuff, right? Blue thing I got from this. Color is so good, guys. Like all the stuff you learned first semester that's making you better in second semester, the color thing is the thing you're going to learn in second semester that would make you good if there was a third semester. Big yikes.
You'd see different shades.
Then you'd be used to it by now.
My dad.
Yeah.
AD and BF we need to relate, right? See how AD only belongs to this triangle and BF only belongs to that one? So odds are those are the 2 triangles I want to get similar, right? If you look, AE, yep, only belongs to that. BE only belongs to that. So these are the 2 I'm interested in. This is important because some of these diagrams have a lot of triangles, right? I want those 2. So here's what I'm going to do. Notice that in this triangle I already have a right angle, so 1 angle down. And in the other triangle I have a right angle, so another angle down. If I can get another angle, I win. What do you see? Andrew.
Is A a shared angle?
It is not with the 2 triangles we're interested in, right? It is shared with this this big triangle, but I want these 2 triangles. So again, you'll see a lot of shared angles, you see a lot of vertical angles, you see a lot of LPT, right? But mark the ones you care about.
Wait,
Why aren't those 2 both shared angles? Like, why aren't those 2?
So A is shared with the big triangle, but I'm interested in these 2. Is A shared with these 2 triangles? No, right? They don't overlap. B is shared with the big triangle, right? But I don't care about those 2. I care about these 2. And I know that because those are the sides I want. AD is only a part of this triangle. BF, only a part of the small triangle. AE, only a part of this triangle.
So you're not worried about like the whole thing together?
Yeah, I'm not worried about the whole thing. Again, identifying what you want is important. Natalie, what do you see? What about it?
Could they, since like they both have angle E, right?
could they be something?
They will end up being congruent, but we don't know that yet. This is not vertical angles because it's not an x, right? Will all three of those add up to 180? Yeah, but maybe that's 30, maybe that's 60, and maybe that's 90. I don't know, right? Mark.
I know what to do. Isosceles triangle theorem.
See how the whole thing's an isosceles triangle?
Dean.
Marissa,
What?
you need this.
Sorry.
Nope, don't be sorry. Like, personally, I don't care. I'm just trying to help because I think you'd appreciate it. Yep. All right, so these two angles are going to be the same by isosceles triangle theorem. Remember that? Jenna, you feeling good about isosceles triangle theorem? Good. So we're going to say by isosceles triangle theorem, that's where if the sides of the triangle are the same, then its opposite angles should be the same. So the big triangle, right, is isosceles. So its bottom two angles should be the same. The big angles or the angles on the triangle are A, B, C. So across from here is A, across from here is B. They're going to be congruent. So I'm going to write that. Angle A, which I can call it just angle A because there's only one angle A, and angle B. If you wanted to call it DAE and FBE, go for it. So now do I have enough angles to prove these triangles similar? Yeah, I've got a right angle in both and a blue angle in both. So by AA, they're similar. So by AA similarity, I'll start with the left side triangle, ADE. Let's match them up. Angle A in the left side triangle is blue. What's blue in the right side? B. D is the right angle in the left side triangle. What's the right angle in the right side triangle? F. What's your profanity? E is the leftover angle. And E's leftover over here. So they're going to go together. Turns out they will be congruent, right? We didn't know that before, but now by CSP we could prove that, right? That they have to be. So now what we're going to do is we're going to talk about their sides, because that's all they care about, right? Now, I could write down all three pairs, right? AD and BF, DE and FE. I could write AE and BE. But if you want, I only care about AD and BF, right? And they go together, so I'll write that. By CSP, AD and BF go together. The same way that I want AE and BE. Do AE and BE go together? Yeah, they're both first and third, right? So I can write that. Could I also write DE and FE do? Sure. But I don't care about those, so I'm not going to write them. If you want to write them all, go for it. Everybody forgets about first and third. Don't forget about first and third. Okay?
That's the one I forget the least because you say that every single time.
I know. There's a reason I do what I do. I have the illusion of chaos.
Mac, I did it.
So these two are the same, and we're done, right? That's what they wanted. So it turns out they're related. Does that mean that they're the same length? No. It means that whatever AD is, it's going to relate to FB somehow. So if AD were 4 and FB were 2, the relationship is double, right? So that means this, when you double it, would get this side. That's all that's saying. Do I know it's double? No. It could be triple, it could be quadruple, it could be a quarter. I don't know. Next one, 5. We might not get to PPEG, guys. If we don't, that's number 6. It will be on the quiz. I'm not joking. It will be on there. Watch the first hour review. They got to it. AC and BC are congruent. Guys, I got to go. As soon as I do that, Jenna knows what we're looking at. We got perpendicular, right? CD and AB are perpendicular. Here's CD. Here's AB. They hit at 90. So that's 90. And then, of course, the other one's 92, right? Because they're a linear pair. So if one of them is 90, the other's got to be 90 because they got to add up to 180. FE and AC are perpendicular. Here's FE. Here's AC. So where they intersect is perpendicular. That's 90 and this is 90. We're going to prove sides similar. Now, we have Triangle City here, right? We've got lots of triangles. 1, 2, 3, 4, 5, 6, 7 triangles here. These aren't, right? So which triangles do we want to get similar? Well, look at what they want. They want side AE. What's the only triangle that side AE belongs to? I mean, it's part of the whole thing, but like, what's it part of? This guy, right? AFE. Right? So we want that triangle. That's a triangle we're interested in. So we want this one. Definitely, because AE is the only AE only goes with this triangle. Now, AC is this bit right here, right? So I want that side. But notice that AC belongs to two different triangles. AC belongs to this triangle here, right? And it also belongs to the whole thing, right? So we still don't know enough. AF further confirms we want this yellow triangle, right? AD is this. So what triangle must we be talking about? We must want what other triangle?
ACD.
ACD. That must be the triangle we're interested in. So those two, does that make sense? So could I get the others similar? Sure. But those are the ones I want. And now that I know what I want, I can go after it. Notice in the pink triangle that we have a right angle already. And in the yellow triangle, we have a right angle already. So we have one angle down. What do you see?
They share A.
They share A. See how the pink and the yellow both share A? Also, Jenna might have noticed that this is an isosceles triangle. So by isosceles triangle theorem, we get those two angles, right? And that would give us the angle we need, right? So we'll do shared angle. That's fine. By shared angle. So we actually had extra information in this problem. Angle A is congruent to angle A. Again, it's the only angle A, so we can write it. Now, pink triangle has a right angle and a purple angle. Yellow triangle has a right angle and a purple angle. So how do I know they're similar? By what? Come on, by what? AA similarity, thank you. Yep.
Would you have to write down the isosceles thing?
You could to get that angle, and you get both of these, right?
Yeah.
And that would be another way to do it. We saw a shared angle, so we did that.
Okay.
Either way works. This one had extra information. So by angle, let's do the pink triangle first. That's triangle ACD. Let's match up the parts. In the pink triangle, angle A is purple. What's purple in our yellow triangle? Also A, right? They share that angle. C in the pink triangle is the leftover angle. What's the leftover angle in our yellow? F, way out here, right? D is the right angle in our pink triangle. What's the right angle in our yellow triangle? E as an elephant. E as an Ellie, who's not in this class anymore. So those two triangles are similar by AA. We want to know about the parts, so I'm going to use CSP, right? That's the thing that allows us to match up the letters. Now, could I match up AC and AF and CD and FE and AD and AE? Sure. But I only care about some. AE I care about. What's AE going to relate to on the other triangle? AD. Cool. So I'll write AD first because it's from my left side and AE second. You could flip those. It doesn't matter as long as you're consistent. I always do the left side triangle on top. See, this guy's on the left. I'm going to write AD on top and then AE on the bottom. Yeah?
Can you explain how AD relates to AD?
So because this stands for corresponding similar parts. So if the triangles are similar, which we said they are, right? Then we're allowed to take the corresponding parts and put them together. See how these correspond because they're first and third? And these are first and third? So they go together.
Okay.
Now we're also interested, we got AE and DE, right? Or AE and AD we got together. We need AC and AF as well. So if you look, AC and AF, are they first and second? Yeah, so they should go together as well. Now we can do that with all three pairs, but I just want the ones that I wanted, right? Now what do? I need to get this to look like that. Multiply things over, right? If we multiply things over, I'm going to get AD times AF. And then I'm going to multiply AC by AE to move it over, right? Now if you notice, we're very close. They just have their equation flipped, right? Are we allowed to just flip the equation? Of course, right? 5 plus 1 equals 6. 6 equals 5 plus 1. Same thing. So I'm going to write it like this. I'll even flip the AE and AC. And the AF and AD. And we're done.
Can we take a break?
We're one away from being completely done. I would like to take a break. 6 will be on the quiz.
What about 7?
7 will be on the quiz too. How much time we got? We're getting out of here at 10:39. What? Oh, it's 4th hour.
10 minutes. 11:32.
All right. I'm not going to get through both if we take a break. You want to try it? What if we did this? What if I don't have? What if you don't write down, but you watch number 6? Okay.
Can I write something on the board first?
Go.
You can start going.
All right. D is the midpoint of AC. So what does that mean? It means that AC, D is its midpoint, meaning that it cuts it in half, right? Cool. E is the midpoint of AB. Here's E, here's AB, cuts it into its own halves, right? Is this an isosceles triangle? Not necessarily, right? Those are two reds, those are two blues. We don't know that they're the same, right? We're going to prove that BC and DE are related. And not just that they're related, but that they're related by double. This is twice as big as this. Okay? Not only that, but that BC is parallel to DE. Okay? So here's what I'm going to do. I'm going to get the little triangle and the big triangle similar.
See A a shared angle.
Yep. So by shared angle,
By Shannon.
angle A is congruent to angle A. Now remember, we've got angle, angle, we've got side angle, angle, or side angle, side, and then side, side, side. If you notice, we've got side angle, side here, and side angle, side. Notice that the sides are proportional. That is half of the whole thing. That is half of its whole thing. So they are proportional. They're both related by half. This to that, and this to that. Are we cool with that? So we have to talk about that. All we've talked about is the angle. So we're going to say that AD relates to AC the same way, so AD relates to AC, the whole thing, the same way that AE,
What is that by?
it's not, and I'll explain in a second, by AB. See how that's half of that, and that's half of that? So they both relate by a half, so they both relate by half. Could I have flipped that and said this is double of that, and this is double of that, and had AC on top and AD on the bottom? Yes. And then I would have had 2 over 1 instead of 1 over 2. Are you good with that?
Yes.
Okay. Now, I don't have to say why I'm allowed to do this. This is just taking stuff from the diagram. That's just it, okay?
So you don't have to prove it.
I don't have to prove it. It's just given from the diagram, basically, okay? So, I've gotten that. So I have 2 proportional sides because they both relate by a half, right? They both relate to each other. And I have an angle in between them. So by side angle side similarity, the small triangle and the big triangle must be similar. So I'm going to write small triangle ADE, similar to big triangle A, because they share it, right? D is made up of the red side and the unknown side. If I go proportional red, proportional unknown, it's C, right? E is made up of blue and unknown. So if I go to the proportional blue and proportional unknown, that's going to be angle B, right? Turns out B and E and C and D, those angles will be congruent. Well, we don't care about that, at least not yet.
Can you explain how they relate again?
Yep. See how in this triangle, A is shared for both, right? So both are A. D in this triangle is made up of the red and the unknown side. So if I go to the big triangle, red proportional, right? And unknown proportional, meaning that they're bigger, but they're still red and unknown, right? Goes with C. And then same thing with E and D. Blue and unknown, blue and unknown, okay? So, 2 things I'm going to get from this. I need to prove parallel, so I need to talk about angles, and I also need sides. So let's get the sides first. By CSP, I know that AD and AC relate. Now, if you look, didn't we already say AD and AC before? Right? So I'll write that in red so you can see that connection. Should relate the same way that DE and CB do. We didn't talk about that before, so I'm going to use a different color. And then lastly, first and third, A and E relate the same way A and B do. Now, here's my logic. If these guys both equal a half, and they equal this guy, what do they all equal? Now, I wanted BC and DE. That's this guy, right? So I'm going to write, therefore, when I flip it, this equals what when I flip this? 2 over 1, which is 2. Now, I'm not done with the proof, but that's one of the things I wanted. Don't be confused. BC and CB are the same thing, right? Are we cool with that? I flip this, so they're all related by double. We cool with that? Right? It was just perspective. Small to big is half, right? Big to small is double. Cool. Are we all okay with that, McKenna? All right. So now we're here, we got that. Now we need to get the things parallel. So I need to talk about angles. So again, by CSP, you can write CSP again, or since that was the last thing we did, you can just keep doing it. I'm going to match up angles. Angle ADE should be congruent to ACB. So I'm going to write that. Angle ADE should be congruent to angle ACB. See how they're first, second, third, right? I could also do EDA and BCA congruent. I could do DEA and CBA congruent, right? But I'm going to do ADE and ACB because if you look, ADE is this angle. And ACB is this angle. So by CSP, those two angles are congruent. Couldn't I do the same thing here, right? AED, ABC, AED, ABC, first, third, second, right? But I only need those. I could do the rest, but I only need these because we know that if we have two lines cut by another and the angles are congruent, that means the lines must be parallel. That's cap converse, right? Normally we say if the lines are parallel, right, then the corresponding angles are congruent, right? But cap converse says if the angles are congruent, then the lines are parallel. So by cap converse, I know DE and CB are parallel. By cap converse, I know that BC is parallel to DE. Swag box. Yes. Are we feeling better about that? I think the weird part is this bit down at the bottom. Will we feel good about the rest? Okay. We're not going to get to 7, guys. I would watch first hour's review. They got through it. Or go back and watch our when we did it on the worksheet. It's the same thing. Okay? It's a lot. Let me talk about 7 real quick. I'm not going to do it, but I'm going to tell you what you need to do. Since these are 90, we're going to say that the small is similar to the medium, the small is similar to the large, and the medium is similar to large. We're going to get all their parts together, right? All their sides, right? We're going to do the division thing. And then we're going to switch out their letters for their small letters. See how AC is the same as B? Then we're going to move stuff around like we do. You'll end up with B squared and A squared, and you'll know what they equal. You'll add them up, and the things that they equal add up. And E plus F is the same thing as what? C. Switch them out for C, C squared. Okay? There is hope. If you want, I'll be here after school. I'll also be here during homeroom. If you want to come in and sit in another geometry class, I have geometry first hour, third hour, fourth hour, and sixth hour. So if you have a study hall or something during those, come on in. Sit and watch the thing. If you want to come in and retake a quiz during your study hall, please do that.
Wait, second hour?
Even if I have a class, I can give you the quiz and you can sit in the back. Why are you not doing this? Instead, you're like, I can only be here after school for 5 minutes because I have cheer and I'll start it and then I'll do it over the next 10 days. And it's like, or use your freaking study hall. I don't know. Kids are dumb. But now you know.
Mac knows kids are dumb because he knows I exist.
This is true. It's because your brains are underdeveloped. There's nothing you can do about that. It takes time. It's okay. It's not an insult. It's a fact.
Remember that time when I made a giant marker sword in 6 hours last semester?
Yes.
I'm tempted to do it again.
And the way that ends